Okay, let's look at question 1D. For t values between 0 and 8, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. Okay, so what is this question really asking us to find? The question is saying, is there, well, first we need to establish what's going on here. So we're talking about, you have water that's being pumped in. We've established this earlier, that's WT. And then we have water that's being pumped out, and that's RT. And the question is there a time when they are the same, when they are equal? Well, if they are equal, then we can also argue that WT minus RT equals 0, right? So what are we actually asking you to find? Well, we're trying to figure out when is it, how can we find out the case that this scenario is true using calculus? Well, you have to go back to, it's a ways back, but y'all talked at one point about something called the intermediate value theorem. And this is from section 18, page 103. And what is the intermediate value theorem? So I'm going to read a little bit to you. A topic that may or may not have been covered in the pre-calculus course is called the intermediate value theorem. It is an outgrowth of our discussion on continuity. Suppose that f of x is continuous on the interval from a to b, on the closed interval from a to b, and let m be any value between f of a and f of b. Then there exists a number c such that c is between a and b, and f of c equals m. Okay? That sounds fantastic, but what the heck does that mean? Well, let's just keep reading here. Let's see how these notes kind of present it, and then I'll tell you how I would say it. The intermediate value theorem says that a continuous function will take on all values between f of a and f of b. To the right is a graph of a continuous function that illustrates the intermediate value theorem. Okay? So what does this say? The intermediate value says that a continuous function will take on all the values between f of a and f of b. Okay, so if this function is continuous, that means that any value between f of a and f of b are being used. So there's a value here which I could call f of, I don't know, x. Well, let's call it not x. That's a bad idea. Let's call it f of, let's go with, I don't know, f of p, right? So if this was like, there's a p value here, this would be f of p, and you have another value here, and you have another value here, and any value, any point you take between f of a and f of b, you have a corresponding value on the graph. It doesn't matter, okay? So that's the first part. Let me erase this so you can see the graph again. And that's all that sentence, that is stating there, okay? That this is saying right here. This is saying here, okay? Let's look at the second part. As we can see from this graph, if we pick any value m that is between the values of f of a and the values of f of b and draw a straight line out from this point, the line will hit the graph in at least one point. That's literally what I was doing earlier, where I was saying any point that we could take, draw it out, it'll pick. They're saying any value of m, so that this is his specific line, right? In other words, somewhere between x equals a, there's x equals a, and x equals b, there's x equals b, the function will take on the values of m. Also, as the figure shows, the function may take on the value at any more than one place. In this case, there are 3 values. Okay? So the intermediate value theorem is kind of stating something pretty obvious, which is that if you have something that is continuous, right? If you have a function, this function is continuous. In other words, it's all connected, right? The definition of continuous among mathematicians is more complicated than that, but let's leave it at that for now, okay? If that's the case, then there is going to be some value between f of a and f of b that exists, right? In other words, if I'm going to go from f of a to f of b, there has to be, let's draw this out. So if I give you an f of a and an f of b, right? If I give you a point, let's call this a, let's call this point b, there has to be, and this thing is continuous. It doesn't matter what it's doing. If I go like, woo, right? Or if I go right? It doesn't matter how I draw this graph. I'm going to be boring, okay? There is going to be some value along between f of a, f of b, any value, any y value between f of a and f of b, the graph is going to touch, right? There's no way I can go from here to here if I'm continuous without covering every interval of y in between. And that's what the intermediate value theorem is saying. Sometimes I hear this being called the duh theorem because, yeah, no kidding, right? If you're going from f of a to f of b, right, and it's continuous, you have to hit every value, okay? That's all that theorem is saying. I understand math jargon is very complicated, but that's all we're saying. Why does this matter in our problem? Well, let's go back to our problem. Well, what am I saying? I'm saying that if I can prove that Wt minus Rt has a value up here and another value down here, right? If I can just find some negative value between 0 and 8 down here and some positive value between 0 and 8 up here, all I got to do is find those points, and the intermediate value theorem says, guess what? It will cross at 0. There will be a y value of 0 in which it crosses. So, how are we going to do that? Well, let's think for a second here. Well, we know from the initial, we have this equation right here for Wt, right? And we also have values for R of t. So what I think you should do is, since we get a calculator, type the value into y equals, right? Keep a note, by the way, when you do this. Keep note of that we are talking about the rate, right? Which is what Wt gives us, right? Liters per hour indicates rate. It actually even says rate, right? So we use the rate equation, type it in, and then when you go into the table, you have all the values from 0 to 8 that work, right? Now keep in mind that we can subtract these RT values. And what are we looking for? We're looking for a place where when we subtract, right, Wt minus RT, you're going to get, we want a value where we're going to get positive and negative, right? So let's see here, right? So if we take W of 0, if you look here, we have 2,000. If you take R of 0, we get 1340, right? So what happens when I subtract them? Well, we don't really care what the number is. We care about the fact that it's going to give me a positive value, okay? So if that's true, why don't we just take the last value, which would be at 8, which is 81, more or less. So if you take W of 8, we get 81, I guess I'll be exact, 0.524, and we're going to subtract the value at 8 here, which is 700. Well, clearly when we subtract this, we're going to get a negative value, right? The legit way of saying this would be W of 0 minus R of 0 is greater than 0, and W8 minus R of 8 is less than 0, right? So if this is true, by the intermediate value theorem, we can say that it will at some point cross at 0. So I guess the next question is, well then, how do we write all of this? Well, what we can say is, well, first we need to define, I guess. So I'm going to say f of t equals Wt minus R of t. So if we are given this, then we can say since ft is continuous. Okay, you do have to say this part here. We do have to state that it is continuous, because if you recall from the formula, it says f of x is a continuous, right? So we do need to make sure that we state that it's continuous, and f of 8 is less than 0, and 0 is less than f of 0. In other words, f of 8 and f of 0 are, 0 is between f of 8 and f of 0. F of t equals 0 for some t that is between 0 and 8 by the intermediate you do want to say this, intermediate value theorem. So you really do, that part you do need to say, and henceforth we can say, actually I think that's sufficient. That's all you got to do. Okay? So hopefully that makes sense, and I'll see you on problem number 2.